In this video example, we're looking at an annuity due, which from our timeline we can see is a stream of payments at the start of the years from time 0 up to time n minus 1 being for a term of n years. Our interest rate will be I% per annum. We'll look at a specific value shortly, and the annual repayment is going to be P. If we were interested in the present value of this cash flow stream, that is, the value of all of those cash flows discounted to time 0, then the expression that we need is P multiplied by A with dots above, subscript N with a corner over it, and that is equal to P multiplied by 1 minus V to the power n divided by D, where, if we remember, V is equal to 1 divided by 1 plus I, and D is equal to I times V, which is I divided by 1 plus I. So if we have n is 10 years, I is 5% per annum, say, and the value of the payment is 5, then P times A double dot 10 is equal to 5 multiplied by 1 minus 1 divided by 1.05 to the power of 10 divided by 0.05 divided by 1.05. This is our V factor to the power of 10, and underneath here we have D, which is equal to I over 1 plus I. And if we perform that calculation, we find the value is 40.5391. So that was the present value, which is the discounted value of the cash flows to time 0. What about the accumulated value? That is the value of the cash flows at t equal to n. In that case, our expression is P multiplied by S double dot n is equal to P times 1 plus I to the power n minus 1 divided by D. If we take n as 10, I is 5% per annum, and again P is equal to 5, then P times S double dot 10 is equal to 5 multiplied by 1.05 to the power of 10 minus 1 divided by 0.05 divided by 1.05, that's our D factor. And plugging in all those numbers, we get 66.0339 as the accumulated value at time 10